Today we are going to study chapter number 13, Motion and Time, from class 7. In this chapter we will study about motion. So what is motion? So motion is the change in the position of the object with time. So if the object is changing its position, we say that object is in motion. The motion are of various types like rectilinear motion, periodic motion and circular motion. Just have a look on the first figure. In this figure, a car is moving in a straight line on a straight road. So this motion is an example of a rectilinear motion. In the second example, there is a pendulum which will vibrate, which will oscillate about its mean position. So this type of motion is an example of periodic motion. And if we take the example of the earth around the sun, it is an example of circular motion. When the object is moving, we have to find out what is the speed of the object. So what is a speed? Speed is the distance covered by the object in the unit time. Suppose a car is covering a distance of 100 km in 1 hour and another bus covers a distance of 50 km in 1 hour, then the speed of the car is more than the speed of the bus. But how much more it is? Since the speed of the object is not constant, so what we have to do? It is keep on changing every time. Like on the red light, the speed is reduced, and on the highway, the speed is constant. So the speed is changing continuously. In that case, we find the average speed of the object. And what is the average speed? Average speed is the total distance covered divided by the total time taken to cover that distance. Now, the motion which an object is executing can be a uniform motion or it can be a non-uniform motion. So when we will say that our motion is uniform? If an object is moving with a constant speed, its speed remains same throughout the journey, then the motion is called as a uniform motion. For example, the car on a highway which is moving at a speed of 60 km per hour. So speed here is fixed, that is 60. So the motion is uniform. Now the non-uniform motion is one in which the speed is not constant, it is changing continuously. Like a car on a crowded road is an example of non-uniform motion. If we want to measure time, so we have to use the clocks or the watches. As you can see on the screen, we use wall clocks, table clocks and watches to note down the time or for measuring the time. Another simple instrument which is also called as simple pendulum, which is a small metallic ball which is tied with a thread and hung on a stand, is called as the simple pendulum. As you can see in the figure, a ball tied with a thread is a pendulum. So this pendulum, when it is taken to one side and you are releasing it, so what will happen? It will move from one end to the another. So from mean, you are taking it to one side and then you are releasing. So it will move back and forth, back and forth. So this type of motion is called as periodic motion or oscillatory motion. When the bob is moving, now see in the figure, there is a pendulum O is the mean position of the pendulum. A and B is the extreme position of the pendulum. So when the bob is moving from mean position O to A, that is extreme position, first extreme position, and then it is going from A to B, that is from one extreme position to the another extreme position and coming back to O only, then it is called as one oscillation. So when the bob moves from one extreme position A to the other extreme position B and back to the A, this is also called as one oscillation. Now, how much time a pendulum takes to complete one oscillation? That can be calculated by the time period. So what is time period? Time period is time taken by the pendulum to complete one oscillation. Now, an activity to measure the time period of a simple pendulum. So for that, we set up a simple pendulum, and what we have done, a thread which is about 1 meter long, and it is tied with the bob, and experimental setup is done. Now move the bob to one side and release the bob. So what will happen? The pendulum will start oscillating or vibrating. Now we measure the time taken for completing 20 oscillation, and what we'll use to note down the time? Either the stopwatch or the stop clock, and record our observation in the table. We are going to repeat this activity 3 times and note down the time taken for 20 oscillation each. Finally, to find out the time period, we take the average and find out the time period of 20 oscillation. If we want to find out the time period for one oscillation, what we have to do? We have to divide it by the number of oscillation. So, if 40 seconds are taken to complete 20 oscillation, so what will be the time taken for one oscillation? That is 40 seconds upon time taken for 20 oscillation. 40 upon 20, that is equals to 2 seconds. The time and speed we have measured, but what are the units? What are the basic units? So basic unit of time is second, and if we have to measure the larger unit, we want to use the larger unit, we can use the hours, minutes, etc. Same way, the basic unit of speed is meter per second, and its larger unit is kilometer per hour. Now see, you are able to see these 3 figures on the screen. What these 3 figures are showing? They are showing the ancient devices which are used to measure the time. And what are these devices? One is the sundial, second is the sand clock, and third one is the water clock. So the sequence are, first is sundial, second water clock, and third is sand clock to measure the time. When these people were not having the watches and clocks, they were using these methods to find out the time. Now, if we want to calculate the speed of the object, how we can find? So, we have to measure the distance and the time. Only then we can find out the speed. So, just take an example. If a car covers a distance of 100 kilometers in 2 hours, then what is the speed of the car? So what is given in the question? Distance covered is 100 kilometer. Time taken is 2 hours. So what is the formula of the speed? Speed is equals to distance upon time, which is 100 upon 2, that is equals to 50 kilometer per hour. Now, if the speed is known to us and time is also given, so can we find the distance covered? Yes, we can find the distance covered by using the formula distance is equals to speed into time. Like speed is 50, time is 2, then the distance will be equals to 100 kilometer. If we know the distance covered by the car and the speed, we can also find the time. So in this case, what is given to us? The distance and speed are provided to us. We can find out the time by using the formula time is equals to distance upon speed. What is distance? 100. What is speed? 50. So 100 upon 50, which is equals to 2 hours. So there are three physical quantities: speed, distance and time. Out of these three physical quantities, if any two quantities are known, you can find out the third quantity by using the formula speed is equals to distance upon time. Now, how to measure the speed of any vehicle? In the vehicle, there is a device which is fitted, and that device is called as speedometer. So what is a speedometer? Speedometer is a device which is used to measure the speed of the vehicle. And in which unit? In kilometer per hour. Have you seen these meters in the cars or the bike? So first of all, the first meter is a speedometer. The needle is moving on the scale, and wherever it is pointing, that is the speed of the vehicle. So right now, what is the speed of the vehicle? The speed is 100 km per hour. Then there is another meter fitted in the vehicle which tells how much distance is covered, and that meter is called as odometer. Just see the figure. The first meter is a speedometer, and the second one is having both speedometer and the odometer, and you can see few numeric digits. So these are telling that how much distance is covered. As you are covering more and more, the reading on the digital scale will increase, and it will give you the distance covered by the vehicle. Now, I have already told you that the motion can be uniform or it can be non-uniform. So how we will come to know that motion is a non-uniform or a uniform motion? We can find it with the help of a distance time graph. So here the graph is plotted between distance and time. Along x-axis, time is taken in minutes, and along y-axis, distance is taken in kilometers. Now see the table. The values are provided. When time is 0, distance is 0. Time 1 minute, distance is 1 kilometer. When time is 1 minute, 2 minutes, distance is 2 kilometer. When time is 3 minutes, distance is 3 kilometer. When time is 4 minutes, the distance is 4 kilometer. And when time is 5 minutes, the distance is 5 kilometer. Now we plot the values on the graph, and after marking the point, we draw the line which is passing through these points. So what do we see? We get a straight line graph. So if a graph is a straight line, then the motion is uniform, and if it is not a straight line, then motion will be non-uniform motion. So you have to keep in mind, if the distance time graph is a straight line, then the object is moving with a constant speed, and if the speed is keep on changing, then graph will no longer remain a straight line. It can take any shape. Now to summarize what we have studied, first is speed. Speed is the movement of the object in unit time. Speed is the distance covered divided by the time. Formula of the speed is distance covered upon time taken. Then non-uniform motion, if the speed of an object moving along a straight line keep changing, its motion is said to be non-uniform, and the motion will be uniform if the object moving along a straight line keep changing its motion is said to be uniform. So if the motion is uniform, then the average speed will be same as the actual speed. Then for the measurement of time, our ancestors were using sundial, water clock and sand clock. The watches which are used today, they make use of periodic motion which repeat itself after a definite interval of time, and one of the most well-known periodic motion is an example of a simple pendulum. What is simple pendulum? A simple pendulum consists of a small metallic ball, and what that ball is called? A bob, which is suspended from a rigid stand by a thread. So when the bob of a pendulum is released, after taking it slightly to one side, what will happen? It begins to move to and fro, and the to and fro motion of a simple pendulum is an example of oscillatory motion or periodic motion. Unit of time is second, and the symbol used is S, and the unit of speed is meter per second. Speedometer is a device which is used to record the speed. It is recording the speed directly in kilometer per hour, whereas odometer is a device which is used to measure the distance covered by the vehicle. Thank you.